is Preet and my partner Enoch. Today we will be discussing our project on American Sign Language character interpretation, and we will be diving into details of what we have created and how it works. Let's get started. So here's the overview. We will be discussing the problem specification, solution design, speech to American Sign Language, references, and questions if you guys have. Let's talk about problem description. So we're going to talk about now problem description. Let's move forward. So here's some overview about our problem specification. As we all know, communication is really important in everyone's life. Some people who cannot hear may have trouble communicating with those who can speak. So the goal of our application to help these people to communicate. So this app can translate basic message between people who can speak and to those who use sign language. You can use your voice or sign language to communicate with others using this app.
Next, we have solution design. The main thing to know about this American Sign Language interpreter is that it will be a two-way communication. In one side, we will be having the American Sign Language to English aspect of it, and on the other, we're going to have the English to American Sign Language, which will enable us to have a two-way communication. And for this, I'm going to go into more depth in the next slide. Now into our data flow diagram. The dataset used in this project consists of RGB images 400 by 400 in dimension. Our dataset contains 70 images per each character from the English alphabet and each number in the range 0 to 9. Little pre-processing is needed for the offline pre-processing step. The dataset consists of all the images which will be fed to a convolutional neural network model, and due to this, the pre-processing for the offline mode will be reduced. During the online training mode, pre-processing will be needed. The live images being captured will be transformed to be of the same dimensions, to have the same background, and to be as identical to the images used in the original dataset as possible, and the test model based on that. The reason behind this is to get accurate results. An API will be used to aid us in the English character to text translation. The character obtained from this transformation will be fed into our model, which based on our Blender model of ASL model, will give us the corresponding American Sign Language characters. And now into the speech to American Sign Language part of this project. As previously mentioned in our problem specification, communication is a fundamental skill in every person's life. And for people with hearing disabilities, um, they often find it difficult to communicate with people that can only speak, and vice versa. This is also the case with people that can only speak. They also find it difficult to be able to communicate with people with hearing disabilities, and this is because of the communication barrier that exists between the two. So this is the reason. This is what inspired this part of the project was to help to break down those barriers, to allow us to have a more to be more inclusive, so that the people on both ends can successfully communicate with each other. And now for the speech to American Sign Language part of this project, we are using a 3D Blender model for it. As you can see in this picture, here it is at the stage of creation. While we were creating the set model. The reasoning behind this is to allow us to showcase the hand sign of the represented speech, so in this case, English to American Sign Language character. Again, this is just an image of the state of creation, and in the next slide, we will be able to see what it actually looks like in a more realistic way after this was finished. And now in this stage, we can see a better looking and more polished version of our Blender 3D model. The word Apple was used, so in this case, we're just focusing on words that are 5 letters and below. Nothing more than that, no complex sentences. As of right now, we're doing just 5 letters. So the word apple in this case consists of 5 letters. Once we fed that into our model, this is the result we get, which is the correct American Sign Language interpretation of the speech word apple. In this case, if we start from left to right, we can see that this character resembling a fist is the A character in the American Sign Language, and then the next two characters after that represent the letters P. The character following that represents the letter L, and the last character represents the E in Apple.
And these are the references for our project. Please let us know if you have any questions. Thank you for listening to us.